Okay, so this video has to do with piecewise functions, and I want to make sure that we have good practice. And I know that you can actually graph these on your graphing calculator, but I want you to understand where they come from. And they are exactly what they sound like. They are functions in pieces. All right, so we're going to talk about piecewise functions, and we're going to talk about the main piecewise function, which is an absolute value function. And the absolute value function looks like this. And basically the absolute value function is I have these two bars here. Whatever's inside here, either positive or negative, will always come out to be a positive answer. Positive number, no matter what. That's what absolute value is. So what does that really mean? Okay, well, let's look at this. So the absolute value, x, is written with these lines here, so that shows the absolute value. So let me do this for a different color here. And that denotes that from a distance 0, it's measured along a number line. So the absolute value, it doesn't matter basically if you're negative or positive, it's just how far away from 0 that you are. So that's why it always comes out positive. So the -3 is only 3 from 0, and the absolute value is 4 away. It just doesn't matter which side you're on, whether you're negative, positive. Okay, so let's kind of look at the absolute value function. So the absolute value function is defined by if it's x, the answer is x, or it's positive. If your x is positive, it's greater than or equal to 0. It's negative x if it's less than 0. Okay, so here's an actual picture of the graph. I've got it right here for you. So 0, 0's on the graph. And then right here is whatever is positive is going to show up here. And so this makes this V form. And this V form is what an absolute value always looks like. So I always remember that because absolute value has a V in it. So that's what the graph always looks like. So I'm going to skip this with the carpet thing. Let's go to this one right here. So we're going to practice with graphing. So this one is piecewise, and it's in two pieces. So I'm going to show you without the calculator. You can always check it on the calculator. But this one basically, what they say is I've got g of x equals x plus 1, and then I've got g of x equals 1. So a lot of times I want you to look at this is your y value. So it's basically y equals. So you've got two functions going on, y equals x plus 1, and you have y equals 1. So you might see it written this way as well, y equals, then you see this bracket, it's x plus 1, and then sometimes you see a semicolon, and it tells you when that happens, when x is less than or equal to 2, and then it's 1, you see a semicolon when x is greater than 2. So what I just wrote is the same thing. I just have two functions going on here, and it breaks. I call this right here, I call this the breaking point right here. See, it breaks at 2, but you'll notice that 2 is only in the top piece because you can't have 2 in both pieces or the function wouldn't be a function. It'd fail the vertical line test. So let's set this up. So I've got y equals x plus 1 is my first graph. My other one is y equals 1. And so I'm going to kind of set up this table here. And I always have the students actually start at the breaking point. So I'm going to put 2 something. And then when I do this, you'll see that that this says x is less than or equal to 2. So I'm going to go down because that's what they said. So I'm going to do 1, 0 something, -1 something, -2 something, and so on and so forth. It keeps going. All right. This one tells you y equals 1 when x is greater than 2. But I still want you to put 2 here. And we're going to circle that because that point's not really on that piece. But it gives you a starting point, and then it says it's greater than. So I got 3 something, 4 something, 5 something. So this is how I would graph these and find some points. So I'm going to just change the color here back to black. So if I plug a 2 in here, I have 2 plus 1 or 3. So the point 2, 3 is on the graph. If I plug a 1 in there, I have 2. I plug a 0, it's 1. -1 is 0. -2 is -1, and so on and so forth. So when I graph these, we're going to put that there. We're also going to put these points here. So it says y is 1. It doesn't matter what your x is. So I'm going to put this here. But notice it's circle because this is not on the graph, but it has to go all the way there. And it's going to be an open circle. Okay? This was 3, 1, 4, 1, 5, 1, and this goes on and so forth and so forth. So I'm going to actually draw this. Let's pick a pretty color. I'll pick this blue. Okay? So let's do this left piece. I have 2, 3 on the graph. 1, 2, 0, 1. Then I have negative 1, 0, negative 2, negative 1. And I don't have, I think you probably can draw straighter than I did. This is that part of the graph. And I have a little arrow here. And that's that part, the first part. So you always graph left to right, top down. So this top piece is always on the left. This part is on the right. Usually how it's set up. Now this other piece says 2, 1 is not on the graph. So I'm going to show you this. 2, 1 is here, and it's an open circle. Then I've got, oops, sorry. I guess I did that wrong. Let me erase that. 2, 1 is over 1. So 2, 1 is right here. Then you got 3, 1, 4, 1, 5, 1, and then I'm going to graph this. And if you'll notice, this is an open circle because if I did the vertical line test, it'd still be a function. But you have to have the open circle there because there's all these points between 2 and 3. So I've just showed you how to do a piecewise graph. All right, let's try the next one. Okay, so here's example number 2. Again, I have 2 pieces, left and right. I see the breaking point is still at 2, so this graph is going to change at when x is 2. So I have y equals x squared is the left piece, y equals 6 minus x is the right piece. And we're just going to pick some points so we can graph this. All right. So I'm again breaking at 2, and the 2 is included here. So I have 2 something, and it's less than. So it just so happens that they're the same. It's not always 2, just so you know. And this can keep going. Here, I'm going to start at 2, but I know that this is not going to be on the graph. So I am going to circle this because this would be an open circle because this point is not on the graph, on this piece especially, because 2 can only be in one of them. Now this one tells us I have to go greater than, so it's 3 something, 4 something, 5 something, 6 something, and so on and so forth. All right, let's start doing the points. So if I put a 2 in there, 2 squared is 4, 1 squared is 1, 0 squared is 0, 1 squared is 1, negative 1 squared is 1, negative 2 squared is 4. And so here's some points that we're going to use for our left piece. Our right piece is I'm going to plug the 2 in, I get a 4, but I want you guys to see something. Do you see that? This is an open circle on this piece, but since these 2 match, it's going to fill in, and I'll show you what I mean by that. If I put a 3 in here, 6 minus 3 is 3. A 4 in there, 6 minus 4 is 2. A 5, 6 minus 5 is 1. A 6, it's 0. So that gives us some points for that piece as well. So I've got the point 2, 4. Fill it in. 1, 1. 0, 0. Negative 1, 1. Negative 2, 4. And it keeps going. If I did negative 3, it'd go all the way up to 9 because that would be squared. So this part of our graph, I'm sure you can draw this nicer than me, is part of a parabola. Now, honestly, the 0.24 happens to be on the graph because it's over here. But really, it's an open circle here, but it's like on top of each other. So the graph is really there. The point's really there. So then I have 3, 3, 4, 2, 5, 1, 6, 0, and it keeps going and going. So this is the other part of the graph. So actually, if you were to see this, you'd never see that open circle. You would just see a filled circle there. It's an actual continuous function. It doesn't have a break in it like the other one because they actually filled in that hole with the same point. So they're like filling each other in. As compared to this one up here, they didn't. It was like this hole was here, this was filled in here, but the hole is below it. Okay, so that's called a discontinuous graph. All right, so I'm going to skip some of these questions here. Now, here we're going to practice this. We're going to graph this one as well. And so when I get to this one right here, this one is easier to graph than the other one, but we'll just practice this a little bit. So I've got two pieces. I've got y equals 2 is one of my pieces. My other piece is y equals x plus 1. The breaking point's at 0. Notice 0 is only in the top piece. And then it goes less than that. So I'm going to go to -1, -2, -3, -4, -5, and so on and so forth. I'm just picking a few points. This one we're going to use a point 0, but again, this is not on this piece. Okay, so I'm going to circle this because that point's not really on there unless they happen to match. And then I'm going to go up 1, 2, because it says it's greater than 3, 4, 5. Okay. So now let's plug in this one. So my piece here is y equals 2, no matter what this is. So this is 0, 2, 2, 2. Get the idea? So this is just going to be a straight line, a flat line with a slope of 0 of y equals 2. So I have 0, 2, -1, 2, -2, 2, 3, 2, 4, 2, 5, 2. So this part of the line looks like this, part of our graph. This other side, I've got the point 0, 1. Notice they're not matching, so this will be an open circle on my graph because it's not really part of it. And then I put a 1 that's 2, a 2 that's 3, a 3 that's 4, a 4 that's 5, a 5 that's 6. And now I'm just going to graph this. So I have the point 0, 1, open circle. Okay, that's important that you notice that. 1, 2, 2, 3, 3, 4, 4, 5, 5, 6. And now I have this going on right here. Okay, so again, this is we call this discontinuous because it breaks, and you can actually pick up your pencil and you can see there's a hole there's a hole here, but it's still a function, but there's a break in the graph at 0. So that's just kind of a picture of how that looks. All right, you can have some that are in 3 pieces. All right, so 3 pieces, it's just you have 3 pieces, and this is what I have. I have a breaking point at 1, and it breaks at 3. If you'll notice, 1 and 3 are only in the middle piece. The other pieces don't have 1 and 3. So I have y equals 2x minus 1 is one piece. Y equals x squared is my second piece, and my third piece is y equals x plus 1. And I'm going to go through and find some points. So I'm going to pick a different color here. Let's pick purple. All right, so ready? I'm going to start at 1 and go down to 0. So this 1 is not part of the graph, and I have to go down to 0, and 0 is included. If I put a 1 in there, I have 2 minus 1 or 1. I'm going to circle that because that's not on my graph because 1's not part of that, but I might need to have an open circle there. 0 is there, so 2 times 0 minus 1 is -1. So that point's the only piece, and it stops there. See how it doesn't go on forever? So that's really the only 2 points I have in that piece. X squared, it goes from 1 to 3, so I have the point 1, 2, and 3. And now this point's really there. I have 1 squared is 1, 2 squared is 4, 3 squared is 9. Those are the only 3 points I'm going to put in that middle piece. This last piece starts at 3, but I'm going to circle this because if I do that 0.34, that's not really on the graph, but I might need that open circle. Then I got 4, 5, 5, add 1, 6, 6, add 1, 7. So I'm having you come up with your own points. So let's kind of graph the open circles first to see how this goes, all right? So the 2 open circles that I have are at 1, 1, so I'm going to do a nice open circle there, and I have at 3, 4, open circle there. And now I'm going to graph the actual other points that are actually on the graph. Ready? Let's do that. So when I do that, I've got 0, -1. So I have 0, -1. This piece goes from here to here. The next piece is 1, 1. Oh, it fills that in. So that's cool. So that's not really broken. 2, 4, and 3, 9. Comes all the way up to 9 here. This is kind of part of a parabola, so it's actually kind of curved. It's hard to see though. Then 3, 4 is open. Then I've got 4, 5, 5, 6, 6, 7. Excuse me, I just did that wrong. Let's erase that. I'm looking at the wrong one here. So it's 3, 4, and then I've got 4, 5. Oh, I did do that right. 5, 6, and 6, 7. That should be a 7. I did do that right. This goes like this. So that's how I graph that function. I will be doing, that shows you that picture there. I will be actually having you find a formula. So we're going to practice this in class before I do this one. So that's all I'm going to do on this video right now, is to have you get that start on piecewise functions. So if I can find where I am here, and I will stop this video.